And these were some that, since I got the wood stove going for the winter, I decided to try heat coating them. They were partially coated, but mostly just at the top still, where they were not in the salt water. Most of the coating had come off from making previous GANs. I think it's kind of evident. It's kind of hard to see on there because of the light. I think where they're darker is where the caustic coating remained on, which seems harder to burn off than when you just heat treat them, heat coat them.
Are you putting the temperature pretty high?
It was, and it kept coming off, and then I moved to just setting them on top of the stove, which is about like simmer to medium heat.
Yeah, there you
You
go.
have on your stove, on a regular stove.
Yeah.
Just let me sort of announce here that this is the Keshe Plasma Reactor Group for Tuesday, November 3rd, 2015, and we're just kind of getting into things here, so anybody tunes in, that's what we're doing. Okay, Jamie, go ahead there, just carry on if you have something there.
This is a steel plate.
A steel plate.
That I've been trying to nano coat. I never had much luck with the caustic of it turning black. It seemed to work better with the heat treating to turn it black than it did. I mean, it's still got some rust color to it, but it seemed to work more efficiently than the caustic coating for getting a black finish on it.
Yeah, black's tricky with iron. There's iron oxide that's black and iron oxide that's the traditional red rust color. And it tends to go red before it goes black. Well, it's harder to get the black. But they do use a black coating now on many tools. You'll see black tools now. They call it I don't know, some kind of black finish, the special finish they call it. But it's an iron oxide process, and it gives that black coating, and it's pretty durable actually, but it has to be done properly. And I noticed it was coming off in my hands, and as a mechanic that was a problem, and it was causing irritation to my hands. So I actually wrote away to the tool manufacturers and suggested they didn't use the black oxide coating. But of course now, 2 or 3 years later, they're all black oxide, I've noticed. Anyway, it's interesting. It's
Do you know what their coating process is to get a oxide?
No, I'm not clear. There are different sort of plasma processes that are used where they stream in some nitrogen or argon and blast it with carbon and so on to try to produce a finish on it. And they may use a flame process. Actually, there's a process they use that way to produce the oxide. So, but it's stabilized is the thing, and so it doesn't turn rusty, because that's the worst thing you want, is tools that turn rusty. Rusty being in terms of the traditional rust color.
Right. I'm not sure what my material's composed of either. It was flashing, but it's not galvanized, I don't believe. I think it was a steel with some kind of
Well, if it was flashing,
coating.
Maybe it was zinc. Would it be a zinc?
It's definitely not zinc. It's very hard.
Oh,
you know,
okay.
for as thin as it is, it's half as thin as the copper and
it's very hard.
Twice as stiff.
Okay. What about aluminum? Could it be aluminum?
No, it's very stiff.
Okay.
I have a piece of it somewhere. I'll have to look. I think I left the label on one so I could look back. At the time I decided that was as close to iron as I could have for manageable cutting plates to make GANs. And it made what looked like CH3 GANs at the time, so.
Mm-hmm. Okay. Are you doing any coil winding these days, or no?
Well, we're all up in the air on that, but yeah, I've wound some.
Did you wind them the right way or the left way?
Right. I should say.
That's a trick question.
It is. I've gone through this for a long time, and then I had a lot of coils that were what I thought was one way, and retired them all to the pile, and thought maybe I'd make gams out of them later. And I have plenty of coils, that's for sure, but I haven't made any full sets of anything until I guess later on this morning. We'll find out, or just go through with it and make them all the same. And the only question to me is if all the connections will be the opposite of
Right.
the way we stick the first wire through the inner loop
Mhm.
and then connect it to the next, and then counterclockwise and clockwise from there. I'm
Right.
assuming would just be the flip flop of what everything was explained before, once we know whatever's clockwise.
I
Yeah.
ended up scrapping my first batch of wrong direction coils.
How do you know they're wrong?
Well, I watched all of what everybody else was doing, and what the directions show definitely wrong. My interpretation of what anti-clockwise was confused. Let me put it that way.
Well, I had my mind pretty set until I looked at now user NA on Facebook was telling everybody that what everybody's been doing was the opposite, and he has results. So his system is up and running, and says he's getting quite a DC load. So
Well, I thought that this was cleared up yesterday, that it's only about the keeping everything the same.
yes, I think that's correct.
Are you saying then that the wrong way coils can be used?
Yeah, there may be
As
no
long as
wrong
you
way.
don't mix the clockwise and counterclockwise.
Right.
Just like on Ghostbusters, don't mix the streams.
Okay, good.
So it's kind of a saving grace for us in a way, if that is the case, because a lot of people would have them one way and others have it the other way, and maybe we can all be happy if there's only a slight difference, if any, in the efficiency. Then
Well,
it's not really
think about
important.
it. If we're sorry, it's getting a lot of feedback.
Yeah, I'm not sure here where that's coming
I
from.
think it's Jamie's mic.
Could be.
Okay, that's better. Move this down, sorry.
There, that's
what was I
better.
gonna say? If we're dealing with a flow, okay, we think about the wires, but we have to think about the plasma flow, and we're dictating that already when we hook the live wire up. So we're dictating the flow already. So does the actual coiling matter, or are we just looking for that flow? Now, according to Mr. Keshe yesterday, we're just looking for the flow. We've been caught up in the matter so much that we're thinking about, oh, if we're winded this way or winded that way. But it's the flow of it. And if we have a interference, as in you're winding your clockwise coil and you say, oh, I shouldn't be doing this and I should be doing a counterclockwise coil, and you put them two together, then you have a difference in flow. Sound right?
It makes sense to me.
Yep.
So was his coils, or was his reactor working? The one that did it backwards?
You mean now user?
Whatever his name was, yeah. It was working. He showed it working.
Yeah, there's pictures on Facebook.
What do you
He
mean
even
by
shows the amount of resistive load that he puts on the system.
Really nice. What's his name? Is he here? Or is he over in China? Where is he?
His name is now a user, but I'm not sure, but I think that's somebody that we've had on here before a few times and actually taught. Is that right? Rick, do you know who now a user
Now
is?
user,
wanna say the
I
name.
don't recall now user. There was some name like that though. Maybe it was now user.
I think it's Nicholas Chua. I think.
Okay.
I can't be sure on that because I'm not sure.
I know he's been at presentations in Italy.
Oh, he has been?
At least some of them. When I first started talking to him, he was sent me some pictures from when they first moved.
Do we have a Facebook page or something we could show?
The only thing on his profile says that he's from the internet.
Right. It doesn't matter. I was bringing that up as I thought that's who it was, but that I could be completely wrong.
Okay.
He's been around for a while, but he's kind of sporadically active.
Right. Exactly.
Hey, Vince, have you heard anything about how the units that shipped out on Friday, how things are moving?
They're moving.
Has anybody gotten them?
Probably not yet.
One of my contacts was MIP, bought one in, I think he said June, and he just received an email that his unit has been shipped.
Yeah, they weren't available in June, but the systems will have been shipped and they're shipping slowly, so we can get a sense of how customs are going to handle this.
Exactly. How long do you think they'll be hung up in customs?
No idea. That's the only way we can find out is to actually send them.
Yeah, I understand.
So we've sent them, and we'll see how they go.
Because when those things arrive, I think that you're going to be able to do the nano coating with the units themselves, which will be a big deal in terms of the process for building these units.
Of course.
I also think that GAN's production might be made easier too. That's just my thing.
Definitely possible. Anybody else?
Well, talked to Dave today, and he's got to make 400,000 units as fast as he possibly can down in Peru.
Rick, I put the link for now user in there.
Thank you. I'm going to check that out.
If I remember his write-up, he didn't mention anything about doing any conditioning work. He just all of a sudden came on and said, you know, I got all this stuff plugged in. I got 2 computers and a coffee pot and all of this and that and this and that. And I'm just wondering how he pulled that off.
We can't actually say that he hasn't gone through it. We can't. He's just showing that he's able to bring that or have that amount of load on there, but he didn't say anything about conditioning. That's right. So we can't assume that he didn't, right?
Well, if he didn't manage to condition it, it means his unit was built 3 weeks ago, and he's 2 weeks ahead of everybody else.
Definitely possible.
Yeah, I'm kind of surprised that he's able to condition it so quickly too.
And it's also possible that he has a better understanding of what we're thinking about, and he found a quick way to condition.
That's true.
Is there? Am I missing something here? Is there pictures that he has, or no? In his Facebook, is that why you gave the
No,
link?
they're on. I think they're on the Golden Age of Gans, if I remember right.
Okay. So I won't put his name up really, because he probably doesn't need the advertising.
Did Mr. Keshe say anything about how his meeting went on Monday? I didn't hear today's talk.
No, he only came in briefly in today's teaching. He was busy in meetings and whatnot, and only came in to tell us that he would be talking about this coil issue thing and sorting it out for us today. And that was briefly the way Vince was talking about it, which is anyways okay as long as it works, which is as long as it goes with the flow. You can apparently have a flow one way or another way, but you have to be
There's
consistent.
been a lot of talk about the exact number of turns, and I haven't been counting every single turn on all my coils, but I'm kind of not thinking that that's as important as some other people think. Any comments?
Well, Mr. Keshe doesn't seem to think it's as important as some people think, because he was giving a range of the coils. Like, it was at one point, I think I've heard everywhere between 160, 170, and 180 for the larger one, and somewhere between 60, 70 for the smaller one. Does that
Yeah, that sounds right.
So,
yeah, I think it occurs to me that as long as it's within the ratio of 2 to 1, should be pretty close.
That was my feeling too.
And then there's talk about, well, it should be in multiples of 9. So there should be multiples of 9 coils for the small one and multiples of 9 coils for the big one. So you get different
no
numbers.
idea where that came from.
Like, well, 9/8 would be 72, and then 140.
I think the first blueprint said 81 and 162.
Right. Well, that would be a good number in terms of nines, and 9 times 9 and 9 times 9 times 2.
But the first day of teachings on last Monday, I believe the range was 70 to 80 and 150 to 160.
Right.
It almost occurs to me when I'm thinking about the like the times 9, the ratios and all of that, is these guys are still thinking in vibrational state.
Right. You're still thinking
that strikes me as they're thinking in harmonics, is in resonance, and
right.
I don't think the system works in a resonance.
Right. It's back to electron thinking that way, and
all
the
I think
formulas.
the thing that's most important, and Mr. Keshe has even alluded to it, and Ralph Ring talked about it, and Lorenzo's talked about it, is that when we make our coils and our GANs, we're putting our energy with our thoughts and our feelings into the coils, which I think is much more important than the ratios at this point in time. And maybe it's a combination of things, but I think it's all about putting our feelings and emotions into the whole building cycle. And as they're going along the cycle, the right thought, the right, attitude, the right emotions, those are the keys.
We also got people that are trying to squeeze out an extra 5%. I want this, what's the most efficient I can make this? You're already working with a device that's going to give you more power than you could possibly use anyway. What's the point?
Well, I beg to differ when it comes to nines. I believe that nines are much more divine, and there hasn't been enough studies that have been done on them. The nines represent also geometrical shapes, and no matter what way an electron looks, the geometrical shape dictates the field flow. So if you got four corners that are at 90-degree angles, they're not the same as nines or operating in base 9 math. Now, I do believe that if you're going to talk about a cascading effect, it's not going to come with not focusing on nines. And if it is, it will be inefficient. So to only be short-sighted and look at the nines as far as just electrons, then that means that we have to think about doing our studies more, because nines have much more significant value than just an electron.
Well, when we're dealing with an expanding and a collapsing system, the expansive side, the most efficient shape that's going to occur on an expansive side is a sphere. The most efficient.
The
Yes.
the most efficient geometrical shape is going to be an egg.
Not in a balanced expansive system. It's going to be a sphere.
Well, are you saying that the planets are not shaped like eggs and they're shaped like spheres?
The only reason they're not absolutely spherical is that they're spinning and there's centrifugal force pulling the equator out.
Either way that goes, that's still the geometrical shape. You can't null and void the shape just because you like to hear the name spheres. The spheres are based on base 9 math.
Please don't insult me. There's no need for that.
Oh, I'm not.
When you're looking at a radiating field from a singular point, and all elements of that field are equal, it's radiating in a sphere. There's no other shape it can be. But in a collapsing system, it must be the smallest volume shape, which is a tetrahedron, which is 4 points, 6 sides. There's no 9 involved. I'm not saying 9 is not important. I'm saying that it doesn't equate to what we're doing here, or at least it doesn't directly equate to what we're doing.
That's your interpretation of your education. Now, what I'm saying to you is that nines absolutely factor into this. Now, another thing that I would like to add is that if the planets are oval shaped, you want me to stop looking at the shapes that I see. You want me to stop looking at the shapes that I see that's in nature and pay attention to a geometrical shape that is basically an equation. I look at nature and I focus on nature, and nature tells me that I don't see perfect spheres. We only see ovals. So the tetrahedron is what can I say? It's a construct a bit, yeah. And you're using those lines in the wrong geometrical patterns, because there are no straight lines or no 90-degree angles. The planet and the universe uses vortexes. Okay, so and nowhere in a vortex are you going to get a perfect sphere. So why would I pay attention to it?
It's the torus shape. Did you hear about the vortex math with Roding Toil, for example?
I'm sorry, what did you say? Did I hear about the what?
You hear me? Hello? Hello?
Yes, I hear you. Yes, Annabelle, yes. Go ahead.
Hey, hi everybody. This is Anibal. No, I was saying that if you know something about vortex math, for example, the Roding coil is based on vortex math, and they use the torus as a shape. And the number 9 is crucial. They divide this torus in 9 parts, and that's the the point. Let's say I don't know the word. We can use the plasma field or the etheric field for them, where the energy comes from back and forth to this material world or physical world. and they use this coil with the shape of a torus, a donut. That's what I'm trying to share. It's not spherical nor oval. It's a torus, and they divide it in 9 parts. Yes. Mm-hmm.
Okay, does the planet look like a donut, or any planets that look like donuts?
No, but if you see the fields of the Earth, they emanate from the North Pole and come back to the South Pole, and they create a torus. It's a torus field.
Animal.
Well,
Now,
actually,
I think-
in theory, maybe it is, but it's actually not that shape at all. When you look at it, it looks more like a spider than a torus. Because of the push of the solar wind and so on, it totally distorts the Earth's magnetic field. It's not much like a perfect torus as far as that goes. It's not like a
No, I
magnet
agree
with
with
a in and out, that's exact and so on. It goes way out into the
I would say the vortex
outer reaches.
math basically describes more along the lines of the field structure and not the actual fields themselves, like what you're talking about, Rick.
Yeah, well, that's the thing. We need to specify if we're talking about the physicality, which is like the shape of something that we see, as opposed to the fields of that thing. And that goes probably for humans.
But there's nothing to say
as
that the vortex-based math, based on the fields, cannot end up with the matter in the end. But that doesn't describe the structure of that matter in the end.
well,
You're right, Vince.
Okay, the only point that I was making is that I'm thinking that it's a little bit short-sighted when we're looking at baseline math and boxing it in and saying something like it's only looking at electrons. That basically, because this leads into religion. It also leads into travel, space travel. All right, and there are several coils, not just the rodent coil. The ad hoc coil corrected some of the flaws that were in the rodent coil. And there was another coil that was after that. I can't remember the name of it. A few, and they didn't use the completely vortex math. They combined them.
Starship coil after that, right?
Yeah. Yeah. So, look, we can get into the baseline math, and I wouldn't mind teaching you guys all about it. But what I can tell you, it is very short-sighted to think about it just in electrons.
But we also did discuss this on Monday, I believe. Did we not, Rick? I think a whole class in the afternoon was devoted to the angles and the power of 9, or what he was talking about.
yeah, it was towards
So do
3
you
and
think that
9
maybe,
and so on.
if you're counting 181 coils, do you think it's not going to work at 183, or it's going to be significantly less?
Shouldn't it be 100? Shouldn't it be 180? If we're talking about 9.
180, whatever. Yeah.
Now, this is what I'll say to you guys as far as that's concerned. I'm looking for the cascading effect. And I'm trying to use the geometrical shapes that I create in order to create that, so that I don't have to add things onto it. If we're looking for a cascading effect and we can't get it out of our coils, it's probably because our coiling is inefficient. All right. So we need to delve more into that. Now, I don't care.
I'm going to say it's probably our thoughts that are incorrect versus the coiling.
Well, aren't they one and the same? When you release your fields, are you not releasing your thoughts as a plasmatic field? And their geometrical shape, if it's correct, would last longer? Is that not what we see in the construct that we look at?
Yeah,
Yes,
that's correct.
So if that is the case, then what I'm saying is geometrical is going to break down the baseline math. I release my thoughts in a geometrical baseline math configuration. And I'm saying that the coils have to be also thought about that. I thought about making them smaller, to be honest with you.
I'm with you. I'm with you now.
I thought about what we really want to do is we want to maybe reduce the center coils and have a cascading effect of those coils in like a wine glass kind of configuration using baseline math. That was my first thought when I saw the 3 consensual coils. Well, why not make the bottom one the smallest one, so it looks like a martini glass, or in that fashion?
Yeah, I think, Khalil, what we're all dealing with now is we're going to find out that this technology is a lot bigger than what we're starting off with our simple coil. It's going to evolve, and it's going to evolve into a lot of different smart people coming to the table and offering a lot of new smart ideas. And this is kind of what it's all about. So, you know, I think, you know, your thoughts are heading in the right direction. You know, you need everybody and every student needs to be open to ideas and inspirations and put them forward.
Rick, I wanted to ask you and Vince a question about the cascading effect that I was talking about with the 3 coils, on which we made the bottom one smaller. What did you guys think about that?
Open to ideas and inspirations and put them forward.
Rick, I wanted to ask you and Vince a question about the cascading effect that I was talking about with the 3. Okay.
That was fun.
Okay. I didn't understand that one.
One thing that Moran brought up, I asked him sort of an offhand question about the 3 coils, and the one word he used within that explanation was balance. So if we have a smaller coil at the bottom, we're actually introducing an imbalance into that what is eventually going to wind up, I would assume, to be a toroidal field. But I'm also looking at this from as many points of view and as many angles as I possibly can, with my own understanding. And he did stress balance.
Well,
Yeah.
one of the things that what Dr. Walter Russell talks about also is balance, logarithmic balance. Okay. Now, if we were looking at the fields, remember the matter doesn't matter at all. Okay, so the configurations for the actual copper doesn't matter. We're looking at how we are generating and creating the fields and the geometrical shape of the fields that we're creating.
Right.
So if we're doing that, then I'm saying that the logarithmic balance is probably going to come with the shapes. I'm going to get very technical with this, where even the length of the coils will be based on baseline matter, as well as the circumference of the outer side of the outside coil to the inside coil. I think all of that improves the efficiency, because when I played with those rodent coils before and the ab-hob coils, it was small little tweaks that jumped from maybe 70% efficiency to 150, and it was something very simple. The adjustments on those things, yeah, and they are like fingerprints. So each one of them have their own individual personalities. I think that the coils are the same way.
Well, that's really a function of resonance. And if you look at any musical theory, if you're out just a little tiny bit, you lose the resonance. So yeah, I can totally understand with the rodent coils and the others, where you're dealing with resonance, that matters massively. But I don't see a resonance factor within this system, at least not yet anyway.
Okay, so we have to step down that plasma, right? We have to step it down, because when the coil's created,
first you have to create it. So
create it.
Where's the plasma that you're creating? Where is it exactly?
It's coming from the coils, which I configured.
No, it's coming from the GANs. The coils are only picking it up. The nano coating on the coils is a wire for the plasma. It's a way for us to direct its flow. That's it. That's all it does.
Well, all right. So my point is this: if we're stepping down the plasma, okay, then the signal that's coming into the house is basically like a frequency also. And Keshe said that you needed a signal. That's all you needed, right?
To use it for the conventional products that we have now, yes.
Okay, so
they're designed around 50 cycles or 60 cycles per second. So yeah, I could see that would be necessary, certainly.
Well, the way I look at it is the signal is to initiate the plasma. In this case, it's the signal goes into the core, which produces the plasmatic field in between the coils.
But the stepping down to electron vibration energy is a stopgap measure. In 2 years, we're not even going to have electricity. We won't need it.
I agree with that, 100%. But I'm only talking about how we configure these coils to be as efficient as possible so that we maybe leapfrog around some of the stuff that we're going to have with this winding and who do you know, these guys were throwing their coils on a barbecue pit today, eh?
Yeah.
Yeah, and that's the thing about it is
this stuff has been done for thousands and thousands of years. We've got evidence that the pre-pyramid civilizations had this technology. So it's
Well, they
easy.
did.
Anybody can do it.
They did. And in America, in New Hampshire, they have Stonehenge, as well as the mountains that are all over the Americas. Okay. And when you go down to South Africa, Michael Tellinger did a very good job of producing what he called musical stones. They had a patina on them, which I believe is just a nano coating. And they used the nano coating and the resonance from the nano coating to create those tones. So once again, I think we're going back to just a signal. And that's what I mean by stepping the plasma down. I'm giving the intention. Like if it was in alchemy, and you need to seed the stone with a little bit of gold. So I'm saying that the signal is acting as the same way. It's the intention. This is what I want out of the plasma, and I'm putting my intention into it in different stages to step it down for what I want. Eventually, we won't need it.
Awesome. I'm looking forward to your results.
But Molly, I think that the other than the shape itself of the coils and the relationship of the number of turns, I think that the critical part, really critical part here, is the quality of the nano coating. We need to be absolutely sure this is not just the color, because a carbon coating could be similar to a nano coating. And we need to be very sure that we are getting a nano coating. That's the most important part. And I'm really confused about the processes, because the document released by the R&D department of the foundation, which encourages the use of torching, don't match with the experiments that you guys, most of the guys, the knowledge seekers are doing. And also yesterday, Chandra was commenting that the torching of the copper will make it brittle, will crack very easily. So I don't get it. I think the original method, which is the caustic plus some plastics and maybe some aluminum, will work. But if we are not 100% that the layers are created, the efficiency lays there. I think that's the main point we need to discuss or be, agree in that.
What do they do at the factory might be one question. As far as I know, they use the fire technique there.
In the coils, you're talking about the coils that the blue box, the Magraph's power?
Yeah.
Well, I think so, because if you try to make 1,000 or 1 million units, a nano coating with the process of caustic will be really, really slow.
Right, so and it's also more toxic and more dangerous and so on as well. So
I'd like to have a try at mass production, because I believe that the fire is one that we have to. It's a bit of an artistry, and I believe that there is a sweet zone that has to do with this. And we were talking about this earlier today. I was like, you know what? I'm going to use base now math even with the temperature. So I never get it over a certain temperature, and I think that it's an art that comes to it. I've seen several other kind of mass manufacturings on where they heat up things, especially the porcelain. It was one of the reasons on why I thought that cold porcelain would be very good for this, for these projects, if not at the very least for bringing the children along.
So when we get our first unit working, or we get our blue box, these units, I believe, will be able to nano coat other units very, very effectively, just like they're going to nano coat the wires in our house. So as we look at mass producing, I think that the plasma technology is going to be part of our toolbox in that new manufacturing cycle. I don't think we're going to have to go through a manufacturing cycle where we're going to take out a blowtorch and blowtorch all of these units.
No, I was thinking of something along the lines of just in the beginning of production, so that we start to produce a huge amount of them. Yeah, eventually you should be able to take about 10 blue boxes hooked up in series and hook the coils up to them and just let them nano coat them.
Well,
direct.
one blue box.
Yeah. Okay. Well, I was talking about maybe 20,000 coils at one time, but I understand where you're coming from. Yeah, that's correct.
Because they're going to nano coat the wires in our house, and they're going to nano coat the wires in our neighborhoods. You know, maybe it's not one, maybe it's two, but you know, I think you're going to find that the capabilities of not only this particular generation, but the product that's right behind it, the generator, is going to be the solution to the manufacturing cycle for larger quantities. That's my thoughts.
Hey, Rick. Rick, I'd like to know if you guys know anything about cold porcelain. You can do a screen share, and I can show you guys what I'm talking about as far as that's concerned. If you
Okay, go ahead.
I've never done this before, fellas, so please, I'm really new to a bunch of stuff. If
you click the screen share button, and then you'll get an option of what you want to share. What you want to share needs to already be open.
Yeah, pull up the image first.
Screen share. I see three things: a whiteboard, an iPhone, and a desktop.
Did you,
you need to
bring up your
have
image?
what you want shared open on your computer somewhere?
Yeah, I do.
And then it'll come up on that in that box.
Well, they're actually web pages. So would you be able to see the same thing that I see?
Yeah, we're looking at your screen.
Okay, so
select your
if you just want to do
browser
your
window.
desktop, if you're not worried about showing everybody what your applications are, then you can just do your desktop.
Yeah, if you guys can see that, can you see this now?
Yeah, we see your screen there now, your browser.
Yeah, I see it.
Okay, so when you talk about how to make cold porcelain, one of the things that I was thinking about was what Keshe was talking about a while back when he said that the ceramics would be probably the best for everything. You know, so the first thing I did was I did my research on transistors. And what I found was that a lot of the high-end transistors use porcelain. So what I was thinking about was how could I incorporate the porcelain into the manufacturing of the GaNs? And my first thought was to make an indefinite battery. And I was going to do it by incorporating the GaNs directly into the cold porcelain. If we go over this cold porcelain, it's very, very beautiful because each one of these ingredients can be changed out. You can change out the corn flour and the cornstarch for whatever you like. That's why I thought that this would be beautiful for the paint pens, because now we can start talking about using the blue-green algae with a mixture of spirulina and these things, and you can make it. I mean, this is completely creative. You can change out almost everything. And it says here that you just take 240 milliliters of cornstarch, 240 milliliters of white glue. That's Elmer's white glue that the children use. That's another reason why I wanted to do it, so that they could be introduced into being able to create things that work, like a battery pack for their toys. The 2 tablespoons of lemon juice, lime juice or vinegar, and lotion, okay? It says here that you have one of 3 ways of making it, okay? Now this is the first way, all right? And that's mixing 1 cup, 40 milliliters of cornstarch and 1 cup of white glue. And you use a microwave bowl, okay? Now, you mix the 2 tablespoons of baby oil and 2 tablespoons of lemon juice. The alternatives listed ingredients, you know, I think that you can change this with almost anything. I was even talking with my group about using battery acid, you know, like, because I would like to see what that battery acid actually holds a charge. And if we can get it in the encasing of some coils, what would happen? I really want to play with this in every single facet that I can. So this is just something that I came up with. It says here that The lemon juice is not vital for consistency, but is strongly recommended as it inhibits the growth of mold. Okay, now we can change that out for a few things like grapeseed oil or some other kinds of things. I'm clearly talking about pain pens or medical apparatus at this point, not energy. All right, now with the energy, I was thinking that the acid can be battery acid. I mean, if you got protective gloves on and you're doing it, you let the cold porcelain dry. It may be a way of recycling that shit rather than throwing it down the drain and killing the planet. So I just look to try and transmute energy. One of the prophecies said that man would evolve when man could transmute, and I'm very much an alchemist. So that's where my base is, and that's why when I teach, my group has a lot of GANs because I recommend to them to go out and scour every piece of metal that you can get and get a GANs of it. In fact, now, Rick, I think what we've been doing and what we've been talking about is I want to find an old rusty gun and GANs the shit out of it, because nothing says peace like GANs in those guns. They put a lot of effort into that blue steel that they make for those weapons. I want it as a GANs. I want to see what happens. So we got an alternative of 15-second intervals in the microwave with more stirring. The microwave, go ahead.
I got a question for you. Don't you think that mixing matter with GANs won't weaken the effectiveness of the GANs?
I think it will. What I was thinking about was I was going to follow the same processes that Keshe did, right? Where we put a pure GANs around the system itself, but I can encase that in a myriad of other different kind of GANSes. And basically what I'm trying to do is just create as many what do we call gradients as possible. So or it's about the conditions. So I'm just following that if I set in motion certain conditions, what am I going to get out of it? So that's really what I'm looking at. I mean, when you're talking about the cold porcelain, you could actually mold the cold porcelain and inject a line of pure GANs around it and let it dry. It's not going to go anywhere. That's the point about this. Yeah.
Now, Khalil, did you hear Mr. Keshe's talk earlier on, probably in some of the classes, about the possibility to put together 3 or 4 different types of substances to create one GANs, and how that happens? With the CO2 container, the newer ones have the 6 sides to them.
Yeah.
And you can take all of these components and, a lemon, oil, whatever, and have them create GANs by having another nano-coated thing on the opposite side of it, and you can do it all together into one soup, if you will. As a matter of fact, when we talked about this GAN soup, that's kind of how it's being done. And all of these things, and I know you're doing a lot of the different GANs, you can combine a lot of them to create the one bigger GANs that is something that nobody has ever come up with before, that may have properties that are unlike anything else that's ever been seen.
That's what I'm trying to do by having people all over the countries GANsing all different kinds of metals. We were talking the other day about, one guy called in on the radio, and he was talking about a type of metal that's inside of dryers that he retrieves all the time. I guess I'm not really sure what it is. I told him to remove it and GANs it. Let's see what it is when you remove it and GANs it.
Maybe it must be nichrome.
Probably the nickel chromium heating element. As far as I know, chromium is really hard to nanocoat.
He called it something like, oh man, I don't know. Is this public?
Tungsten, could be tungsten.
Well, we already started with the tungsten welding rods, and shout out to Rick, because I thought that jewel from him. You know, like I ran right with it. As soon as he threw it out there, I said, go get some tungsten welding rods as much as you can. But I've got people that can actually operate the CNC machines. So there's a lot of different metals that come from there. We're getting the GaNs of carbide bits, everything that you can think of, as long as it's a alloy. I told them to GaNs it, and I think that when we combine them together, you know, we're going to get something is going to happen. I've even got these guys that are doing silver.
So remember the coil, and what you're trying to do is the atomic number that you're really watching for. So these ones that have the higher strength, you're going, if you can think of it, is you're going deeper into the coil and pulling out more possibilities, if you will. So things like the higher strength metals like tungsten, that's the direction to go.
Correct.
You make the GaN with a regular method and the nano-coated copper plate and the salt water. Is that the way you create these GaNs of other metal?
Yeah, we're creating the GaNs from just the nano-coated wires, but this is another thing that we started doing today. We were hanging plastic bags with a nano-coated wire on the outside of the plastic bag. We were using things like coat hangers to open up the bag so that we increased the surface area. And then what I told them to do was follow the rules of alchemy and seed your reactors. Don't just, say, well, I don't see anything. Seed them with a little bit of GaNs water as to put them in the direction that you want them to go. If you can get what you want from plasma, then a drop of CO2 GaNs inside of there should start the process of creating it. I'm just looking at this purely from plasma.
Just with an external wire around the plastic bag and the seed of CO2 and salt water. No another metal. You don't use another metal, just the nano-coated copper.
We would like to move into where we are actually manufacturing the GaNs without the metals coming in contact with the water, so we can increase the purity. All right. So what I'm looking at, especially with CO2 GaNs reactors, because everybody keeps saying that, well, we can't get anything out of them when we put the wires on the outside. And I'm saying, okay, this is what we're going to do. Take the plastic bag, the Ziploc bags that you throw things in the freezer with. Okay. Take it and fill it up with the salt solution that you would use for your reactors. Okay. Then tape the wires on the outside of the bag and seed the water on the inside. And seed it with what you want. I mean, if you're creating the conditions, I have to, because this is something that Keshe talked about, that there's been an anomaly. I've had people tell me that they're making GaNs, and when they disassemble their GaNs reactors, that there's still GaNs being made.
And in your experience, it worked? Do you see the GaNs, increasing in quantity?
I don't know. We started yesterday. But we started yesterday. What I wanted to do was I really wanted to get a very high level CO2. So since I got a group that's actually, their house is on a highway, I was like, well, it's got to be huge amounts of CO2 in the air where you're living. So I'm trying to take the armpits of what these societies have to offer us and start to convert them immediately. So if you live by a highway, then you basically have a CO2 GaNs factory right there. So why not figure out?
But you keep your...
Go ahead.
Yeah. No, sorry. You keep your bag open to the air, right?
Yep. Keep the bag open to the air with we used coat hangers. Yeah, and we punctured 2 holes in the top of it so that we could hang it. You know how you have a railing on your house, and there's like, it's like a picket fence, but it's made out of steel. A railing. Right? You have those openings. Each one of those openings, we put a bag inside of there. Right? And we left it open, and it's by the highway. So I'm thinking, by seeding the reactor, right, putting the coils on the outside of the plastic bag, which is a very thin layer, which means that you're going to have an interaction. can I start to produce a very, very high or pure CO2 that is of a different magnitude? And if we do that, can I do it with other things too? Like, do I need the copper to be on the outside, on the inside? Can I just put the copper on the outside and then seed it and start to get the CS3 or CO2? Can I do that?
Okay, so let me go back to the experiments that were used for creating food, where I did an experiment where I took a nano-coated cup. I put a plastic cup of water on top of the nano-coated cup, and I put a peach on top of it. And after 2 days, I pulled the plastic cup with water out of the nano-coated cup, and I drank the water. And the water had, and I put a CO2 GANs next to it. The water had the taste of the peach, and in my mind, that water was GANs water. In other words, it had the GANs of that peach in the water. So when we're talking about the metals, it's one thing, but I think that some of the processes can be as simple as utilizing water as your tool to bring about a GAN state of the water to do whatever you want. Now, when they did some of the healing things, they did the same thing where they did the essence of oil next to the nano-coated cup with a CO2 GANs next to it. So I think what you're going to find is that the whole concept of what is a GANs may be opened up in our ability to work with some of this plasma fields.
Okay, so let me throw this one out here to you then, because this is an idea that I had, and we've been implementing it, but I think that there's still various results, so I haven't really talked about it. And that is, we're looking at a condition, right? So let us look at a watermelon. A watermelon is 96% water, okay? Now the question is, if we want to create a GANs, we have to have what they call a salt solution in the water, right? All right, so if we take a hypodermic needle and we push it inside of the watermelon, okay, and then we put the nanocoils on there, all right, can we create what I call an eatable GANs or consumable GANs of a higher magnitude? Because they, if orange juice is a type of GANs water, can we increase the gravitational and magnetic fields of these GANs waters so that they are not quite an alloy where they're too high, and we step them down enough for human consumption? And can then
yeah, okay. I think what you want to do is use water, because water has unique properties, and the water can carry the GANs energy by itself and become consumable. Now, eventually, this plasma generators that we have we're going to find that by placing the watermelon next to it, there's more to it than just that. But eventually, when he has another add-on feature, if you will, we're going to be able to put a watermelon next to it, and the whole village is going to be able to consume watermelon without having drank anything or done anything. It's basically going to be plasma energy that they're going to be able to take as much as they want of whatever they want. So that's where this thing's really heading.
Of course, beautiful thing, because I'm ready to get rid of my lungs and my digestive system. I damn sure am. I'll be the first to tell you that. So yeah, I do believe that. Yeah, but until then, what I'd like to do is I'd like to play with the technology and let us see how creative we can get with it. Like, there are going to be stages before we get to complete plasma absorption. And I think that some of the different stages is where we can be creative and be creators. You know, one of the things that it talks about in the ancient teachings is a magi, or in my situation, a Quetzalcoatl, which is a creator god who brings civilizations, all right, and helps to teach people how to be teachers. You know, it defies the level of understanding where we have to pay for education, because what if none of us can pay? Then who's going to take, how is the knowledge being passed on? It's completely inefficient, and it can't work like that anymore.
May I ask a question? Hello?
Go ahead.
Yeah, Rick, I want to ask all you guys if there is any consensus returning to the coils, if there is any consensus about what's the better way to go with the coating, the nano coating. Do you think it's the best way to torch it or the, because I have 24 coils already done, and I am not sure, because, you know, as you already know, it takes time, effort, and I already did 12 of them because I saw this PDF showing that they must be tied to each other. So I rebuilt 12 of them. And now in the process of nano coating, I'm, you know, hesitating because I don't know what is the best way to go. That's why I'm asking if there is any consensus of this, what's better.
I don't think we
Plasma.
know yet, because we don't have the results in from all the experiments and the thousands of units that are out there. If it works, then do you want something that's better, that works better? Is that what you're thinking? You're afraid to do it in a
No,
certain
what
way?
I'm trying, no, what I'm trying, because this is an experiment that, you know, if it can be done in a couple of days, it's okay, you know, trial and error, do it again, and so back and forth. But it takes a month, you know, once you do the system and you create the guns, immerse those coils in guns, let it dry, blah, 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 and then start little by little, you know, loading them. It will take like 3 weeks to 1 month. So then after 1 month, you can have an idea of the efficiency of the system, and maybe 5% or 95%, who knows? That's why if we have any feedback at this point, we can save some time and then improve or go from there and try to, you know, get it better and better. But, you know, starting from something that makes sense, because there are so different opinions.
Right.
And for me,
Okay.
what they posted in the PDF is
Well, that's easy. That's easy. You just wait another month or two, and we'll find out what's going on.
Exactly.
I'll share that, you know, I tried both processes, the torching of the coils and the nano coating, and I liked the quality and the consistency of the hot caustic method much better, and I felt more comfortable with the product versus the heating. The heating, I had a little bit of a problem with, you know, what was the exact right temperature and how do I get everything, you know, at that exact right temperature, because if you overheat them, it's a problem.
Well, that's right. So there's a lot of techniques
I
out
think the
there.
key is don't, you know, try to start with one. Don't try to start with 6 of them at a time, or you're probably going to end up with, you know, 6 mistakes versus 1 mistake.
No, I'm doing one for my use, another for my neighbor. We are doing it together, so it's that better. But you know, we were ready to start with the caustic process. When we saw this PDF showing the torching, we stopped saying, well, maybe the group will know better, or. But since there is no any opinion that goes in some way or the other, but I think that I agree with you, John. I will go with the caustic, the original method.
Sure, go with whatever you feel comfortable with. You know, Renan happened to introduce the heat method, and that's what they're doing in the Philippines, and apparently he has good results with that. but that doesn't mean that you're going to have good results with it, or I will, or whatever. It all depends on individual techniques and maybe the particular atmosphere in your particular area or something like that. There's so many variables that it's
I
difficult
agree.
to say. Different kinds of copper, different kinds of heating techniques. Some say to use the butane or propane, and others say just to use electric heat because you shouldn't be introducing other particles into it, and so on and so
Correct.
forth. So there's different
Electric
concepts. And
heat, you said?
yeah, like you
Yeah.
can use an electric burner or oven type of
Because
thing.
I was thinking use a current. What if a
Well, that's another way to do it. You could actually put a current through the wire, heat it up enough to turn it almost red hot, and then
well,
in fact you could
in
keep a
that way,
current in.
since you can control the current, you can control the temperature. That's why I
That's
like
right.
that. But I was in doubt. Though. I don't know. We'll see.
Yeah,
I love that idea.
yeah, and
Love that.
it may be that when we run these units, that when they're initially run in for the first couple of weeks, that might be part of the process, is that gradual heating, and the heating keeps the nano coating process going and makes it all sort of more solidified into the environment, so it's interacting with the environment more and so on.
Yeah, if you put it in a cold caustic, making the cold caustic solution, and then put it the coil with an electrodes on the ends and regulating the current and watching with a measurement of the temperature, you will reach like 300-400 degrees. It will make a lot of bubble, but it won't get red, and it will start interacting with that environment, and then it's a matter of time and watching till it gets dark or black, and that's it. It's a matter of trying. I don't know.
One thing you're going to have to really watch out for if you're using current to heat your wire, the purity of the material, the density of the material,
Correct.
which is going to be all over the place within the wire, and its actual physical dimensions all have to be absolutely perfect, or you will never get it the same temperature all through the wire.
Do you want to stop the
I didn't
screen
follow
share
that.
so we can put in the different screen share? I think we're done the
Yeah.
porcelain part here.
Do you want me? You guys wanted me to finish this? The only other thing that I wanted to add about the cold porcelain was that I was looking at this for the what do they call them? Capacitors. I was looking because if you need an inert, something that's inert that will not catch fire, then I'm thinking that I can actually make tubing that I can use for my my capacitors using this cold porcelain method here. And if
So
I wrap the nanowires around the cold porcelain before it dries, I can basically set in grooves so I don't have to worry about the nanowires ever escaping off of the capacitors.
Yeah, because porcelain is normally a very good insulator, so I'm not sure how that's going to work with the capacitors. But maybe if you put something special in it to make it so it's more plasmatic or something, it may possibly work.
GaNs.
Why don't you try it and see if it'll work?
That's what we're doing.
Right
That's
on.
what we're doing.
Okay.
So yeah, you guys can take the screen off if you want it.
Well, you got to stop it, bud.
Okay. How do I? All right, I'll
Set the
stop it.
options and stop screen share.
Okay. I stopped it.
Okay, good.
All right.
And let me see what they have. So I just thought we could put coils up. Well, we talked about coils here, so we see
guys,
what do we have. Those are Ubix coils. He's got some other ones here.
Rick, can you hear me? This is Robert.
Yes, hi Robert.
Hi guys. I had this idea for a while now. I don't know how practical it would be for nano coating. I was thinking if you put your copper coils or wires in a caustic bath and put it in a microwave and heat the water microwave, and the metal being in a microwave would heat up also. But you know, I don't know what kind of an effect you would get.
Sounds like you're gonna short out your microwave.
Well,
It'd
not
be a
really.
fun video for someone to do, I think.
Yeah, well, not
Any
only that.
volunteers?
If you want to see basically what's going to happen to the wire structure, the actual molecular structure of your wire, take an old CD that you don't want anymore and put it in your microwave. What's going to happen is it'll crack up into quarter wavelength little squares. Like they won't be perfect squares, but it'll look like a checkerboard after it's done. And so you're going to wind up with an incredibly hot spot every quarter wavelength of the 2.4 gigahertz that the microwave runs on throughout your wire. It might work. From what I understand, the RF theory and how metals react in high frequency radio waves, it's just going to cause problems.
Yeah, the only problem, hello, it's Shandor here. The only problem is all the safety instructions for the home use microwave ovens says don't put any metal into them.
Well, I did some research on that. Apparently, if you have metal utensils, let's say spoons and forks, the spoons will not arc. You can leave a spoon in your microwave and nothing will happen. But if it's a fork with sharp ends and corners, that's where it's gonna arc. So I'm thinking if the coil is in the water, it's in a liquid submerged, the liquid will sort of distribute the heat, and I don't know what kind of an effect you would get, but I've never gotten to trying it.
Yeah, it's not a bad idea. It's something I'd consider it as well.
If you try that, take some distance from the microwave just in case.
Yeah, it's a very dangerous proposition to be having hot caustic inside a microwave where it could explode, and then you would have hot caustic all over everything, essentially.
Yeah,
and
like
it's
like
very,
Jamie
very,
was
very,
quoting in a pressure cooker.
very, very serious situation. Even
And remember that caustic can blind you.
yes,
Leave
well,
you
one drop
blind.
is enough to blind you in your eye.
Take care with caustic, because if you have a caustic spill, you don't wipe it, it dries. Later you touch it with your fingers and you will find very serious burns.
Yeah, you can get into the nerves of your fingers and whatnot too.
There was a guy that I studied. I'm pretty sure that his videos are on YouTube. And he was actually taking glass and he was creating gold and platinum out of it. I can't remember his name off the top of my head, but you can probably just go onto YouTube and you can find it. And he was using microwaves.
Yeah, I've
He
seen that.
was using crucibles inside of the microwaves in order to do it. So, maybe his methodology may be something that you can incorporate into what you're talking about. You can take a look at his videos there on YouTube. I think all you have to do is something like gold from glass or something like that.
Yeah, there's lots of YouTube videos with microwaves, and some of them are useful in a sense. And there's actually science experiments that are going on with just ordinary household type microwaves. There's one that creates an actual plasma using a microwave that exists for about a third of a second or so as a plasma ball in your room. And there's another one where you can create a plasma inside a microwave by just simply putting a grape in there and microwaving a grape.
Yeah.
It
I saw that one.
turns into a plasma. But that's like a, sort of a high temperature type plasma, not the kind of plasma that we're necessarily interested in. Maybe you could put a microwave in the middle of your coils and actually receive some of the plasma energy from a grape that was turning into plasma, perhaps. I'm not sure about that, but definitely there's room for experimentation there for people that want to try that sort of thing. But I would not advise I cannot advise a microwave and hot caustic. That doesn't sound like a good combination. Same as boiling hot caustic is a bit tricky too. but people do it and get away with it.
The HHO guys, they have something. I couldn't remember exactly what it was, but they were tampering with that also. That the entire genre of HHO, Brown's gas, these guys, they were doing something with the microwaves also. I'm not really sure what. So I'd definitely go over those HHO guys also, because they got some good stuff in those videos.
Yeah.
Hello.
Hi, P. I saw you had your hand up there. Go ahead.
Yeah, and I'm just want to add, like to hear if somebody of you had the experience with the stove. For example, if you make the coating in the stove, can you eat? Can you make food afterwards in the stove?
You mean like in an oven, for example? Is that what you
Yeah,
mean?
an oven, exactly.
Yeah, the oven isn't hot enough to create the nano coating, as far as I know. But the stovetop burner would, like on a coil on an oven, or not an oven, sorry, on the stovetop that you would cook with your pots, pans. That can get hot enough to, for example, heat up pennies or a coil of copper and that sort of thing. I don't think it would be a problem at all to have a bit of black nano copper fall down into your coil of your stove or something. It's not a big deal. It's not something that you would want to eat a spoonful of or something like that. No. But
Yeah.
Or if
the
you have
nano
nano
coating,
coated.
the nano coating's not super toxic as far as the black copper oxide. You just have to be careful with it and not get it, all over yourself. It's in nanoparticles they can be dangerous in certain ways, in certain configurations, and that's the thing. You don't really know what shape nanoparticles you got until you have them analyzed, and not too many of us, if any, have analyzed the surface to actually see what we have in terms of nanoparticles and whether they're of a shape that might be more dangerous than other shapes and that sort of thing. But essentially, it's not that big of a problem. It might be more of an issue if you had GANs covered coils that you were baking in your oven or something for some reason.
Yeah,
Yeah,
Pia,
exactly.
I was working with a fella who's doing an experiment with a kiln, and we were working out temperatures that he should work with. And what we came up with was somewhere around 900 degrees Fahrenheit. Your oven is only going to get a little bit above 500 degrees.
Yeah, I was going to
So,
say 400 or 500 degrees centigrade would be one of the sweet zones for copper, for example. And most
yeah,
ovens
you want it
only go up to about
just
300.
below where it turns red, which should be
Yeah.
about 1100 degrees. So we thought
Hmm.
somewhere around 900 to 1000 would be about right.
Right. Yeah. Yeah. Yeah.
Okay, so I can forget everything about my electric oven.
Oh yeah.
Pretty much. Pretty much.
Yeah.
Yeah. Yeah. You'd have to you could preheat it if you wanted to in the oven, and then use a torch, and it would go much faster and easier that way. As you could have it on a Pyrex, or preferably a ceramic tile kind of situation, and it could be in your oven preheating, and then you just use the torch, and it wouldn't take as much energy from the torch to give it a good coating. Plus, you'd have the inner coil heated up nicely that way too. So there might be a use for it that way, but generally, or it's also, an oven can be used to dry the coils once they're covered with GANs. That was mentioned yesterday as well.
Yeah, if you're going to dry in your oven, keep your temperatures below 200 degrees or 100 degrees Celsius.
That makes sense.
Yeah.
And and generally, it wouldn't be a problem. That's not like the GANs is going to evaporate and get all over your stove or something. It's more sticks to the coils, but depending on what your GANs water was, generally it's mostly water, so it'll just evaporate. shouldn't be a big issue unless you have all kinds of weirdness in there. Somebody's talked about mercury GANs in the plasma group today, and they were going to make mercury GANs, but that's pretty much highly frowned upon because mercury itself is dangerous enough, and any of the GANs from mercury would probably be 100 times more so. So, and then if you put that in the oven, well, good luck. You better evacuate the neighborhood in that case. I don't know what would happen, but it doesn't seem advisable to use toxic stuff in your oven in any case.
No.
Unless you have a kiln. The kiln would be a better situation. So.
Yeah, but also like fire maybe would be the most easy.
Fire seems to be the most easy and quick.
The CH3 GANs, that might be rather volatile because there's so much hydrogen in it. But the other two, the carbon dioxide and the copper oxide, no, they're pretty much inert.
Yeah, but I won't like to make a big cake after this, you know. I had to do this in my stove.
Gee, this cake tastes funny.
Yeah.
GAN's cake.
Yeah. But I've done a little bit of fire coating. I've done some cold caustic, hot caustic. I much prefer the hot caustic method. I get so much better results with that. It's always consistent. It's always the same. As long as you say follow the same procedure, you know it's going to work. So I'm just going to go that route. And I used to work for a place in Richmond down by the airport, and we had a hot tank about the size of two buses long that we used to soak everything in. And so doing a massive industrial hot caustic method is not really a big deal. We've already got the equipment to do it.
Yes,
but
true.
with these coils, John, with these coils are really heavy. So I think that I was thinking that if I decide to go with the caustic, it should be a lot of it. I mean, not caustic, but a lot of gallons of water. And so when you immerse the coils, it won't alter the temperature. Otherwise, it will pull it a lot because these are heavy.
Yeah, you could preheat the coils. I was thinking about that myself because even with the one reactor that I'm making, it's way too much material for the little containers that I have. And I'm thinking, like a 10-gallon or a 15-gallon canning pot on my barbecue to boil the water, so I can boil 15 gallons at a time. When you're dealing with this much mass, this much matter, yeah, you got to think on a large scale. And to preheat them, to get them up to 100, 150 degrees in an oven or something beforehand, yeah, I can't see how that would hurt it. It'd probably work better.
Yeah, but the problem is that you need to preheat it and get everything done ready, and immediately throw them on the chicken wire and start the process, because otherwise it makes no sense, because since this metal is so conductive, it will cool down immediately.
Oh, it's not so more complicated than a 3-course meal. Just a matter of timing and planning out your steps first.
Yeah.
I have a question about plasma coating. And the question that I have about plasma coating is it the same characteristics as caustic? Because if it's not, then we can actually just plasma coat the copper wire before we even form it.
How do you do coating?
I would think coating with plasma, you would have a more what's the word? Not coherent. I can't even think of the word.
Are you talking GANs or plasma?
He's talking about using the plasma to coat with.
Right.
What's the source of plasma?
What plasma are you specifying?
Let us go through the 4 stages of nano-coating, which you have nano-coating with caustic and electricity, nano-coating with just caustic, nano-coating with fire, and then nano-coating with plasma. What I'm asking is because
Now, you won't be able to nano coat with plasma till you have a plasma reactor.
correct.
to
What,
be able
what
to-
I'm what I'm asking is about mass production. Okay, if does the nano coating that we do with plasma, does it have the same characteristics of the other three? Can we actually nano coat the wires before we even form them? Like, has anyone seen what the nano coating looks like when you do it with a pure plasma device? Like if you had a magrive unit and you nano coated with that? Is it flexible then to where we can actually form it before we can actually nano coat spools, huge amounts of spools with the plasma, so that basically all we have to do is form the coils and it's done?
The nature of the nano coating, if you were to take a nano coated wire and bend it into a circle, whatever's on the outside of that circle is going to get ripped apart. There's no way around it. Now this is on an atomic scale, so it's going to disrupt that atomic structure. The I don't know if it's a crystalline structure that it's created on that. I think it's probably pretty close to a crystalline structure on the outside, which is not going to be a flexible. Say that again?
Does anyone know what the structure is? If it's nano coated purely in plasma?
Nobody knows what the structure is to begin with. It's all conjecture, and what we understand is that it's pulling the atoms off the surface, not enough to release them into the environment, but just enough so that they increase the space between them, which reduces the field strength between them and allows the plasma to flow through. So when you manipulate that wire, you're actually going to alter that structure somewhat. That does, and I don't see, it doesn't matter whether it's plasma coated or heat coated. You're going to manipulate that structure when you move that wire.
Okay, now when we're dealing with caustic, we're dealing with actual real matter. Now, if we're dealing with plasma coating, nano coating, wouldn't the plasma, because you're using that same plasma anyway, wouldn't it actually nano coat all of those gaps?
What gaps? What gaps?
It would do this. It would do the same thing. It would do the same thing with a caustic coating. The issue that we're having is, especially with what Moran was teaching, people want instant results. They want to make it, they want to cook it, they want to put it together, and they want to see something happen. They don't want to wait 2 weeks for it to fix itself so that things can happen. So that's why he's saying, don't, try not to mess with the wire, because you'll damage the coating. And it doesn't stop the thing from working. It just delays it from operating at efficiency.
Yeah, but that was my point that I was looking at was, if we're going to be using the same exact kind of plasma, because a pure plasma system can nano coat wires. So if we have those wires nano coated, even if the surface areas have gaps in them, because we're using the same kind of plasma, would it not be nano coated over eventually and create a uniform surface or a uniform fields?
Sure, it just might take a few months, so you'd have to have months to make each coil instead of minutes.
Well, remember what he said about turning on and off a light switch? Every time we turn on and off a light switch, we go back and kind of start over again, going from the matter state to the plasma state. So if you had a nick on your wires or a gap, it will re-nano coat itself when you plug it back in.
Correct.
Right, but it just might take time to do that, like nano coating the wires in your house or whatever. The same as an example, look at the connections on most car batteries. You'll see some corrosion forming on one terminal, and if that's allowed to continue, it'll start growing and growing, and eventually it gets right into the copper cable, and it'll start running all the way up the cable and deteriorating it until it falls apart. And that's a different kind of copper oxide, and it's a different kind of coating process that leads to deterioration, and that's not the kind we're interested in. But it just shows how it grows. It grows from its seed, you might say, and because of the fields around it, it just continues to spread as a nano coating. some cases quite vivid, which can be fuzzy blue coating on the electrodes of a battery, for example.
But one of the interesting questions will become is when we plasma coat our wires, will we need to have the GANs to put on them after that, in that they already have these, they're already carrying these plasma fields?
Or what if we turned it in our favor and we nano coated the wires before we formed the coils, and then use the GANs to fill in those gaps where we're actually inserting GANs in deeper crevices or embedding it into the coil. And then
Well,
just
it gets into the problem. Are you saying you would already bend the coil and have it already formed before you do that? Or
I think that I'm saying that I would nano coat it when it's on a spool, and then I would make the coils.
Yeah, well, that doesn't work so good because nano coatings don't like to be bent and handled and so on. They tend to flake off and otherwise not be consistent.
Is that the same characteristics that it would have if you did it with plasma also?
I would think so, yes. You got to remember the nano coating itself is the wire for the plasma. The wire, once it's coated, is just structure. It does nothing. Just holds the coating up. That's all. The coating is the wire for the plasma. So it needs to be as coherent as possible with as little occlusions in it. Otherwise, you're just going to obstruct that plasma flow, and it's like water flowing through a creek where the banks have fallen down. It's going to back up and get lots of pressure there, and it will eventually blow all that through and run through. But again, like we're saying, it's going to take time. So you want as clean and smooth and free of flowing conduit for the plasma as you can get.
Okay, well then, how about if we started to maybe think about eliminating the copper, or eliminate
that came up in the last workshop. Mr. Keshe has talked about that for about 8 years.
Yeah, that's
now.
coming up where we make the system, we nano coat it, and when we apply a process which removes 99.9% of the copper out of it, you wind up with just this cylinder of nano.
So then I would like to throw out an idea, and I hope that it adds to the knowledge. I was thinking about this about a month ago, and we were really going in on this. And the idea that I came up with was using the 3D printers, all right, to produce a mold for being able to just pour the copper. And the mold, it should already have the coils in consensual order, already hooked up, everything already done. Yeah, and we pour the mold in there, and the mold can be paper thin, nano coated, and then we have nano tubing, which is what Keshe said is the most powerful, correct?
Well, as a mold maker, I can see where you're going with this, but I'll tell you that would be incredibly difficult to do.
Well,
I tried the nano tubing, and I don't believe that you get the creation of plasma fields with the tubing as well as you get with the coiling. And if you notice, all of his activities has been towards this concept of the coiling, and you see it on a lot of the other things. It's all about the coils.
Right. We can actually pour the coils. We can pour the coils in a mold. And with the 3D printers, we can get a lot of detail, especially with some of the really, really expensive ones. All right. So, and a CNC machine is also something that we could probably think about. Because I just believe that if what we're looking at is 1 kilo of copper, just so we can access the surface area of it, let us figure out how we get the rest of that copper out of it.
Well, with the 3 layers of the coils, the outer spring, the inner spring, and the single wire going around the inside, there is simply no way to do that in a mold. Okay, that's not possible. You can do each piece separately and put it together later, but
Correct.
You can't do one single thing in a mold. It's not possible. Simple as that. So the efficiency that you're looking for by doing it in a molding system just kind of evaporates because it's so fast to turn coils.
Can I paint a little picture for you, Khalil? Where we're going with this, in my mind, is that these plasma generators, or not generators, but plasma power centers, are going to be creators of plasma fields for us. And with these plasma fields, a lot of the people are going to become plasma manipulators or plasma users. And when you get to become a plasma user, you'll find out that you have the ability to create anything you want. So
Yeah, you
the
won't need the
first
device
units
anymore.
that we're making, we're now walking into this brand new territory where everybody can become equal. And as we have, our first units, remember he's talking about the spaceship. Now we don't need a single bolt or single screw. We're having a little bit difficult time using just our mind right now, but these plasma generators are going to help us see exactly what it is that we could do that we thought we couldn't do.
Yeah, for example, one thing that came up in discussion, for example, he mentioned that you take your reactor, you condition it, it's running really good. You walk up to it, you put your left hand on the reactor, and you throw out in a pulse the thought of apple, and an apple appears in your right hand. This is where we're going with this, and eventually we're not going to need the machine. This is the
Well,
tool to teach us what plasma is and how we are already plasma.
Well, the teachings that that are in several of the Aboriginal teachings in America, they talk about this very extensively. So we're well aware of all of this, being able to be creators. God creates with plasma. So since God is within us, then we are gods. And that's what we teach, to be creator gods, to go out and create. So yeah, I understand all of that. But right now, the only thing that I'm throwing out is ideas. I think that the best part of creating is to throw out as many. Not very many of our ideas are going to make it past, a few feet. But the processes of throwing them out there will create something better. So I understand exactly where we're going with this. There are some people that I believe were in, if I'm not mistaken, it was the Assyrians. One of the things that they taught was to envision roses in your mind and then try and smell the rose, which is a very low level of what you're talking about right now, which is creating the things in your mind. So being a creator God is where we're going with this. So yeah, I'm pretty aware of that.
Yep, and I've mentioned to a couple of people now on Skype groups and in a private chats. They're looking at, well, how can I make this more? How can I make this efficient? I want to make this as big as possible. And I'm like, well, why? You're going to have unlimited energy in a very simple, non-restrictive, ridiculously easy to make device. Why would you even think of 10% efficiency increase? What's the point? Unlimited is unlimited. I mean, how can you have infinity plus one? It doesn't work. It's either infinite or it's not. You know what I mean?
I'm looking at that nanotubing because I think that once we have it, we'll be able to decrease the amount of copper that we need, or probably be able to decrease even the configuration of the coils, where they can be much more open because they're completely nanotubing. So there's a lot of different geometrical shapes that we can choose when we're going into just making it completely a tubing. Yeah, and we're going to increase the fields, and it'll make it a lot easier to create. I think that Keshe is just showing us how to concentrate our own plasmas. I really
the next generation reactors, he's already released it, that they're going to be about the size of a pancake.
Yeah.
One thing we'll run into is
wire.
We don't want to use a smaller cross section of wire, like in micro tubing. Would sound good in terms of it could be nano coated inside and out. You'd think that'd be the best, but It may be that this particular device has to be able to transfer a certain amount of what's called amperage to
this
run
device,
it.
yes, definitely.
So
Because this
if we
this
were
is
to have
our
the
bridge.
same diameter wire, but it was hollow, it may not work for this example. It may work better plasmatically, but it may not work on the matter level to be part of the initiation of this particular device.
But the size of the copper, supposedly it won't matter because we are talking here about the plasma circuit. Let's say the transfer is through the plasma. So
That's depends. Are we or are we not? That depends. Is the actual is there an actual flow of electrons through this system? And if there is, then they need the room to be able to flow. Unless they are flowing in a superconducting and type manner, in which case that's a different situation. But if your device was superconducting and then suddenly part of your nano coating broke down and then it became conducting, then you want to have the matter level wires or something's going to go up in smoke.
You're right, but I think that the size of the copper matters after the connection to the system. With the size of the copper, because all the system does is transfer energy from the plasma into the lower level of maggrav to the matter level, let's say, and when it exits, through a cable, and the size of that cable matters, not the size of the system. Maybe I'm not sure, but that's what I'm reasoning.
Well,
electricity through a superconductor, there's not going to be any heat.
Okay, we have to think about also the principles here, yeah? And the principles here is that we want to move into completely plasmatic energy systems, all right? So the electron will be eliminated at some point completely. So what I'm thinking about is more from a conditioning point of view versus continuing to think in the lines of how can I manipulate the electrons. So that's why I'm saying that the tubing will decrease the amount that we'll need, because we will have conditioned our systems so that we can receive plasma in much higher volumes.
Makes sense.
In a superconductive nano state, you won't have to worry about the volume of material, even the nanomaterials, because even at say 500 atoms diameter piece of nanomaterial is going to be able to transmit an infinite amount of plasma energy. It's a superconductor. There's no resistance. All it is a pathway that the plasma likes to flow through. And
exactly.
size, once we get into the plasma, the size doesn't matter.
Yeah,
the size is.
I'm thinking about the conditioning to accept it. You see, fellas, that's all I'm talking about. You got a lot of people that are looking at this, and the only thing that they're looking for is exactly what Keshe said, is electrons. They want a few electrons. I think that the funny thing about this is that he clearly told a lot of people that you can create flight very easily once you have a stacker or this kind of apparatus. But as well, we can create medical devices and we can feed ourselves. And still, people are only thinking about how many electrons can I get out of it. Yeah. So,
But remember, man, that we are still interfacing with the old system. That's why we need to do that.
And that's what I'm talking about.
And also remember that it's part of our job to educate people, to let them know that these systems are more than just the electron level stuff. And it's more than just your percent off your hydro bill that you're getting.
Technology, yeah.
Yeah, I'm telling everybody I talk to about this. The electrical output is a possible byproduct. Not
right.
Thank you.
Good way to put it. Good way to put it.
Exactly.
It's not what the prime thing is.
Just like having matter. Like once we have the conversion device where we have our maggrav reactor and we set this conversion device beside it and we push a button and get a glass of water, that's a byproduct of the plasma. It's not the output of the device.
We can create light, energy, whatever. Yeah.
Right. And I think that it was Dr. Walter Russell that really opened my eyes to this when he said that light doesn't travel, it only reflects. And it took me a while to understand that until I did my studies into what Keshe was talking about with the interaction from the magnetic gravitational field of the center of the planet in combination with the sun is what creates the friction that causes the light that you see.
Yeah, it's the interface with it's the friction, the leftovers of the interaction of those fields.
Yes, yes. So it all made sense to me then. It was all plasma. And it's just about directing it and slowing it down to what you want it to be.
Yep. Yeah, so we have a superconducting ultimate plasma unit sitting on our table that produces all the plasma we could possibly want. Let's go from there. I mean, you know, I'm not worried about whether this thing is 90% efficient or 98% efficient. I don't care. I could care less if it's 10% efficient.
Yeah. Yeah.
I've got so much to work with now. I'm already past that. I'm okay. This thing works. I know it works. I'm going to have this kind of energy. What can I do with the energy? That's where I'm going with this.
Yeah. Yeah. I started to just try and create in my mind as much as I can. So that's why in my groups, listen, I don't think that you guys, we're not going to really have any fun until we really got a lot of people creating these things and we're enjoying what we're doing. I continue to tell people all the time, the best part of life is fun.
Well, I'm really looking forward to when I hand one of these devices to the Quechuan people down in Peru, because they are intensely spiritual people. And when the shaman sees me walking in with this thing, what he's going to see is this big bright light. He's not even going to see me. He's just going to see the plasma and he's going to go, wow, what can I do with that? And they're going to do amazing things down there.
I was in Machu Picchu and yeah, I'm very, very familiar with the cultures down there. And I'll tell you something, they're not only, well, I will be happy when everyone has everything that they need. I will be happy for that.
Well, you'll like this. When we sent our envoy to talk to the Quechuan people down there, the chief of chiefs, the first thing he said was, "We've been waiting for you. Where have you been?" So they know we're bringing this stuff, and they are tickled pink.
And that goes for the Aboriginals, I think, all around the world now.
Thank you.
There are a couple of groups that have been in contact with the Keshe Foundation. I think it's called the Five Nations in New York, and also the Mohawks in Ontario and Canada, and a couple of other groups are also interested. So I think that actually this type of technology, this plasma technology, and hopefully through the Keshe Foundation, is actually going to unite these native tribes together, because it is the common denominator that is the same for all of us everywhere. You know, plasma is plasma is plasma, and it is the future, and it is the future for the natives and Aboriginals in all the country. I mean, look at Canada, where I live, where I come from. And we have, I was just on the news today, we're number 7 in the world in average income, and we used to be number 3 a couple of years ago, so they're all complaining, oh, now we're number 7 and we have to get better, and all this kind of thing. And yet we have this 20% rate of poverty among children in this country, and a big high percent of that is in the Aboriginal tribes and so on. And you know, the situation up north, where you go up and you got these diesel generators that are generating the power for a town, just polluting everything, and or individual generators for homes that are polluting, and just not, you know, not good, using heavy fuels. And if they can all have personal power supplies, or personal, not just power supplies, but life enabling units, basically, then it just it just changes the whole picture. And all of a sudden, most of the conflicts of the world are going to look pretty foolish, because we don't have to have some tribe in South America against this major oil producing, rig that's destroyed their land and so on, and conflicts there and conflicts in the Middle East over oil and all this kind of stuff. It'll take
We are getting ready to the universal meeting. Let's say that's
yeah.
the first step is to be in peace with ourselves, and then we have a lot of things coming. It's amazing to live, like you said, Rick, once to live at this time.
Yeah, absolutely. Now, Shandor has his hand up and has probably patiently been waiting there. Maybe we should hear from him. Shandor, you got something you'd like to add probably 10 minutes ago?
Yes, it's a subject which was discussed about 10 minutes ago. So Kellel suggested about how about to save copper by having less copper and more nano coating. Of course, to have a nano coating which works, you need some copper below. And the question is how you make a tube from a wire, because you can burn it out, you can remove later the copper, which is quite a difficult process. It's not so easy. But this remembered me to the story which Mr. Keshe told once about the architects had the imagination to build a huge dome, and they didn't know how to do what shall hold the bricks until they make the dome. Once it's made, they will hold themselves. And they announced this request. Anybody has an idea to come up with it? And finally, it was a child who came up the idea. So how about to make a big haystack and to build a dome above the haystack, and later you remove the hay and you have the dome. And that's how they made the first dome. So similarly here, to make a mold, it's very difficult if you work in molding. Furthermore, in casting, you need certain sections to let the molten metal to flow. You have places to release the gas and so on. It's very complicated. It's not feasible. But one of the ways would be to create a support and to build copper over that support, and to build over that the nano layers.
This is what I was talking about. Okay.
Yeah. Now, for the support, for instance, you could use some kind of thread, or not a metal wire, but something which can be molten, like a plastic string or something like that.
Beeswax. Yes.
Wax will not be good for strings because it's mechanically not enough stable. But if you think of industrial product, which involves a high investment, so expensive machines, it's not cheap to make it. It may be possible just to save copper if the copper will become a problem for sourcing, to metallize with copper some plastic wires, and to make the coating on the top of them. That would be one of the ways. But still have to consider that what does it cost more, if it, in terms of cost, what's more efficient economically, to save some copper or versus to invest in a very expensive technology.
You came up with a good idea there. What about plastic wires, nano-coated plastic wires? Maybe that would actually work.
Why not? So
we haven't tried that.
There are methods to metalize. There are methods to metalize in vacuum with sputtering, or physical vapor deposition, or magnetron sputtering. Some plastic pieces. These are used daily in the industry. You just see this. Christmas tree balls, they are all metallized to be shiny and beautiful, and this is the way how they make mirrors. Just they have a plastic support, not always glass, and they metallize them. So there are methods for them. So you can discuss if you have engineers who are working in such technologies to come up with ideas. Meanwhile, recently I just found on Facebook somebody had the idea, genial idea, about how to make even spacing between the threads of the coil. Just a second, let me find that window. I have 100 windows open, so it's not so fast. Just let me see, where is that? I will find it later. So one of the knowledge seekers, I just wish to give credits to his name. Sorry for I was not able to find it so quickly. Yes, I found it, Pedro Neves. I will try to share this screen. So he published it and he shares it. It's no copyright problem, I think. Just let me share the screen. Where is that window? Okay. So it's in golden age of GANs.
Okay.
Hi guys, I think I found a way to space evenly all the coil.
Yeah, I already. Yeah.
And that's the trick. You have to place it
Some of you already
a wire in between two turns. Oh, hope you can see well there. You hold it with a plier and hold it tight and just turn till the end. And
You know,
that's
that's
it.
interesting, but I don't think you want to be doing that. I don't think you want to have that pulled apart. All the pictures we've seen, they were all tight together. I tried initially pulling mine apart, and I didn't like the concept of, pulling them apart.
Mm-hmm.
Well,
Yeah.
what if we did smaller? What if we did smaller, a very small diameter as far as the lead? Okay, so the pipe that you had earlier, Sandra. What if we did a very small wire, small diameter wire, as kind of like a lead? That would create a spacing itself that you could actually glue that coil onto your bar, so that when you started coiling, it would just fall into the grooves, and then you wouldn't have to do anything but just take it off.
Certainly, there are different ways how to do it. My earlier idea, I didn't do it. It's not so easy with two hands only. The earlier idea was to coil together a wire and a plastic string, which would leave the spacing, and a plastic string being like a fishing string.
That's exactly the fishing string. That's exactly what I was thinking.
That you cut it later and you just take it apart and you throw it away and you use up something else. That would be one of the ways. So now the question Joe Bliven told about, he doesn't like the spacing. Yes, there are different approaches, as we told in yesterday's public workshop. There are some reasons for making spacing, and sometimes it's good, sometimes it's not necessary. If you do all the coating process by the fire method, in that case, supposedly that high temperature creates very well the coating within the place where two adjacent turns are touching each other. But when you use liquids like caustic, in that case, it will not penetrate properly. And also when you do the drying process, in that case, touching parts will keep moist and it will not dry uniformly. So to make a uniform nano coating by the caustic process, I consider it's good to have some spacing in between. Otherwise, the coating may fail.
So like, for example, on Richard's, I don't believe that he pulled his apart. And it
No, he did not.
Looked like his coating took. My coating looked like it got in between all the gaps.
He did.
Something I'd like to bring up about that spacing idea, that with you wrap the loop around and run it down the drill again. If you're going to do this, make sure you use dissimilar materials. If you use a piece of copper wire to do that with, you're going to make a horrendous mess of your copper, because it'll pick up and basically friction weld itself together. You need something either significantly harder or significantly softer than the copper, and then it won't damage the coil itself.
Well, I'm from Boston, fellas, and the thing that I was thinking about was the fishing wire, using a high test line fishing wire. and running it in series with the copper wire so that the spacing is there as I coil it. The fishing wire will pop right off and the spacing will already be there.
Yeah, you can try it. You're gonna have a hell of a time keeping it all nice and neat and even.
Yeah.
Having one piece to control is one thing. Having two pieces to control and they have to be exactly the same, whole different animal.
Well, Sandra has a lead that he has coming out of the drawer. So, you know, I looked at that thing and I thought to myself, it's really set up like a sewing machine, kind of. And what I was thinking was that if I were able to take maybe like an industrial stapler, and I was able to run it through both of those, yeah. And I'm not talking about a very thin wire here. I'm talking about deep sea fishing wire, which is a little bit thicker. All right. So, you know, obviously the coils will have some good spacing if we use that, and you can use different test lines of what they call the diameter of the fishing wire. You can use different test lines.
Can I ask a quick question about this?
Yeah.
Is your fishing wire textured?
No.
I would just use a very, very cheap plastic fishing wire that you get from any of the fishing stores.
Okay, if it's plastic, as long as it's significant, if in that case, as long as it's significantly softer than the copper, you're okay. You're just gonna have control issues. If it's harder than the copper, it's gonna actually gall up the copper really bad.
Yeah, I understand. That's why I said the fishing wire, because it's soft. It's soft. It's basically plastic. So
or a cheap plastic, good for tennis rackets.
Yeah, but having a little loop around it,
high end.
having a loop of that stuff around it, held on with a pair of pliers, and you run it down the coil like the guy did with the other piece of wire. If you try both systems, you're going to find that just running it a second time over the coil is going to be infinitely less trouble.
You might be right.
So anyway, there are different methods, and I'm very glad and very happy to see so many people contributing with their own ideas. So this all became now a big global, how to say, contribution work.
Yeah, it's very interesting.
Your ideas are great. If you got an idea, try it. I've been doing manufacturing processes for over 20 years, and I can usually, somebody will bring up an idea and I can see where it's going to go wrong right away. That's why I got paid so much. But you may have a solution that I don't see. So if you have an idea, try it. I mean, it's either going to work or it's not. That's one or the other.
Yep, lots of ideas, guys. We need to wrap things up here because we need to take a break before the workshop begins in an hour. So let's just wrap up our final thoughts here.
Yeah, Rick gets his 20 minutes of sleep a day. That's the only time any chance he gets.
I won't be sleeping either. But yeah, it'd be nice to. Yeah, so.
Eat the copper. You can eat the copper.
You don't sleep, Rick?
I generally sleep. I figure now when I have a new technique where since we have two sides of our brain, the left brain, right brain, I let my left brain sleep and my right brain work for a while, and then I let my right brain sleep and my left brain work for a while. Works fine. But I just look a little dozy. I just look a little dozy half the time.
For the body to recover.
Well, I haven't quite perfected the technique yet. Yeah, thanks, John. Appreciate your input there, and Phoenician, and well, everybody. It's great having input from everyone, Annabelle, and so on. It's great when people all pitch in, and we're not holding back at all. We're ready to not tear each other apart, but tear into the idea to see if there's some substance there and sort of penetrate it and so on. That's great fun. So the more we can do that, the better. And
thanks, fellas. I enjoyed it.
Yeah, just one final tip, because people had issues with different kind of thickness of wires. For instance, in Europe, you have 1.4 millimeter thickness and 1.7 and none of 14 gauge. So that's why my suggestion is to check which wire thickness you have in your walls and in your electric network, and don't use any thicker than that. It's no reason to oversize it and to have a bottleneck when you connect it. So if you see your fuses, if you have a 10 amps or 16 amps fuse, it means you have a 1.5 square millimeter wire, so no need to use for the 2.5 millimeter wire.
Yeah, I wouldn't go any thinner than 14 gauge probably if you're going to be running 2000 watts through it and so on, because that's
Actually for 2000 watts. You have low voltage. You are in Canada, yes, because you
That's
don't
right.
have 240 volts like you have
Yes.
in Central Europe.
That means
So
the
in
wire
Central Europe, you
size.
can go thinner.
That means the wire size has to be double for this area to take the same amperage in it. So that's a big consideration actually that we haven't really thought about. Coils here should be double the size of the ones in Europe in a sense.
No, they are just right, just right. So 14 gauge, it's
Well, yeah,
very good for 3-4 kilowatts. Don't worry.
Yeah, true.
But
It
for
should be able to
220
handle.
watts and for 2 kilowatts for sure.
I
For
think
2
it's
kilowatts is good for
good
the 110.
for about 12 amps. I think it's rated for 14 gauge. If I'm not correct, if I'm not wrong.
So you multiply that amps 12 with how much is your voltage? 110.
Right, and it's not up to
And you
2000.
multiply with cosinus free factor of 0.8. So for 1 kilowatt is no problem.
Yeah, it will be like 1.4 because that's a RMS, a 110 RMS.
Yeah.
There's no correction. It's the amperage times the voltage.
And the amperage might be more like 15 amps for 14 gauge wire as well, I think. I'm not clear on that. I think the 16 gauge will take up to 10 amps or so.
Yeah. 14 gauge, it's enough for low voltage system for about 1.5 kilowatts.
Right.
Yeah.
I'm sorry, Sandra, I did have one question for you about the diameter of your coils, the inside and the outer, and how you came up with that equation again.
With just a second, I have to share my video.
Yeah, I don't want to get into another 5 or 10 minutes
okay.
here. I got to wrap things up. I need a break here. Okay,
right.
but you know, you could.
I know you work hard, man.
You could
do it. Show this one. If this
quick.
picture tells you something, you can take a screenshot and watch later.
Okay.
So this is about 6.5 inch for the external diameter of the larger coil, and the inner coil is just half of it in length.
Okay. Okay.
So this
hey, Sandra, they look pretty good. Those are nice.
Yeah.
Very
and
well rounded.
This is all spacing in. Yeah.
Yep, beauty.
Sandra, you could put 20 of those in a row. You could put 20 of those in a row.
Shut down, Rick.
Breakfast time.
Yeah. Okay.
Thank
you,
some
Rick.
sauce, Sandra. Some sauce. Organs better.
All right.
Everybody.
Time to shut things down, guys. Thanks everybody for coming by, and we'll see you next week. And I hope to have some special things next week that we'll show. So we'll keep it a mystery until then. Alrighty, it's the end of the Keshe Plasma Reactor Group for now. It's Wednesday, November 4th, 2015. Bye for now.
Thank you, Rick. Thank you. Bye-bye.